Hi everyone, I am Khalil Ahmed, Assistant Professor of Physics, and the outline of my presentation is central force. Now, what exactly is the central force? A central force is said to be a central force if it is always directed towards or away from the fixed point. The forces exerted by two bodies on each other from the action and reaction pair and are equal and opposite according to Newton's third law of motion. The motion of a particle or motion of a body in a central force field can be classified as bounded motion and unbounded motion. In bounded motion, the distance between two bodies never exceeds a finite limit. It have a certain boundary. For example, the motion of a planet around the sun, double star, or the motion of an electron in an atom, etc. In unbounded motion, the distance between two bodies is infinite, initially and finally. For example, scattering of alpha particle by a nuclei of gold foil as in Rutherford experiment, which means if you consider a Compton scattering, if photons come from infinite distance and after scattering it scatter with infinite distance. Now let us study what are the properties or characteristics of central force. The first one is the angular momentum is constant. In a central force field, the angular momentum of an object or a body remains constant. And the motion of a particle, motion of a body is a planar, that is two-dimensional motion in a plane. And the central force is conservative force, which means it is a path independent. It only depends on initial and final path. Example is electric force, gravitational force, elastic force, etc. are the example for conservative force. Non-conservative force means it's a path dependent, initially and finally. Example friction, applied force, etc. Aerial velocity is constant. It is a very important characteristics or properties of central force, which means from Kepler's law of planetary motion is nothing but Kepler's second law, law of area. Aerial velocity is constant. Now, what are the examples of central forces? Uniform circular motion is a central force. Force due to gravitation is also a central force. Simple harmonic motion, which is always directed towards a fixed point. Projectile motion, uniformly accelerated motion, electrostatic forces, magnetostatic forces, etc. These are the examples of central forces. Now let us consider the physical insight into the nature of central force, which means the motion of a particle or a body in a central force field. What happens if the motion of a particle consider in a central force field? Now suppose any particle moving under the action of central forces will have not any torque acting upon it, and hence angular momentum about the center of the force remains constant. That is, tau is equal to derivative of L, which means dl by dt. If there is a no external torque acting on the system, then L is equal to constant. That is, the angular momentum remains constant. We already know that. Now let us consider a particle which is subjected to a central force. Now this central force is a function of this position vector and r cap. This mathematically from vector calculus we can define r cap can be represented as or defined as vector r divided by mod of r. We know that the torque acting on the particle is given by vector tau is equal to vector r cross vector f. Now you can substitute that value. Tau vector is equal to r vector into, that is f vector means f of r into r vector divided by mod of r. Now, but r vector cross r vector is equal to 0. From the vector cross product, just like a vector cross b vector, which is equal to ab sin theta, where theta is the angle between a and b. Suppose here in position vector, the angle between these two is 0. If theta is 0, sin theta is 0, therefore a vector cross b vector is equal to 0. Therefore r vector cross r vector is equal to 0. So this term becomes 0. Then the torque is equal to 0 or tau is equal to 0. We know that the torque is a time rate of change of angular momentum. Therefore, derivative of L is equal to torque acting on the system. If torque is 0, then the angular momentum remains constant. Thus, the body moves under the action of central force. The angular momentum of a body remains constant. Thank you very much.